based on what we know about the trigonometric ratios of sums and differences of angles, we can use that information to find the trigonometric ratios for multiples of an angle. And let's attack the double angle problem. So we need to find what is sine of 2 theta, where theta is just one angle. Now you can write this as the sine of theta plus theta. Now what we use here is the sine of a plus b, since it's just sum of two angles, although they are just the same. But anyway, sine of a plus b, that is equal to sine a cos b plus cos a sine b. Now instead of b here, you just need to put in theta, and instead of a also you need to put in theta. So this will give you sine of theta times cos of theta plus cos of theta times sine of theta, which is just equal to 2 sine theta cos theta. So there you go. The sine of the double angle is equal to 2 times the sine of that angle times the cos of that angle. If you wanted to figure out what is the cos of the double angle, so cos of 2 theta is equal to cos of theta plus theta. Now what we do know about the cos of a compound angle is that cos of a plus b is equal to cos a cos b minus sine a sine b. So now instead of a's and b's, you will just write theta. So theta here, theta there, everywhere a theta. Now this will give you cos theta times cos theta will give you cos squared theta. Then there is a minus sign, so cos squared theta minus, and sine theta times sine theta gives you sine squared theta. So this gives you one form of the double angle cosine ratio, that is that cos of 2 theta is equal to cos squared theta minus sine squared theta. And there can be some alternate representations of this as well. So what we use here is the identity that cos squared plus sine squared of any angle, that is equal to 1. And using this, you can write that sine squared theta is equal to 1 minus cos squared theta. So put it in right here. This will give you cos squared theta minus, instead of sine squared theta, you write 1 minus cos squared theta. This just gives you 2 cos squared theta minus 1. And similarly, what you can do is you can write that cos squared theta is equal to 1 minus sine squared theta. And if you put it in right here, this gives you 1 minus 2 sine squared theta, minus sine squared theta, not 2, minus sine squared theta. This gives you 1 minus 2 sine squared theta. So there are 3 forms of writing the cos of the double angle. First is in terms of sine and cosine both. The second is only in terms of cosine, and the third one is only in terms of sine of that angle. Mostly you will use these two, but this can also come in handy sometimes. Notice you cannot use a simple straightforward identity here. If you wanted to, this will just become 2 sine theta times, instead of cos theta, you can do the square root of 1 minus sine squared theta, or you could have done the other way around, where you could have written 2 cos theta times 1 minus cos squared theta square root. Anyways, this is the sine of the double angle. This is the cos of the double angle. What about the tangent of the double angle? Well, there are many ways you could have done this. So tan of 2 theta, you could have either written this in this way, so this can be written as tan of theta plus theta, and then you could have used the formula that tan of a plus b, well, it's equal to tan a plus tan b, 1 over minus tan a tan b. And you could have just put in theta here. This would have given you tan theta plus tan theta would have given you 2 tan theta. And in the denominator, you have 1 minus tan theta times tan theta. So that's just tan squared theta. The other way that some textbooks like to approach this is in this way. So tan of tangent of any angle is just sine divided by cos of that angle. So sine of 2 theta divided by cos of 2 theta, that is equal to tan of 2 theta. Put in the values that we already have. So let's use this cos squared theta here, cos squared theta minus sine squared theta, and let's use 2 sine theta cos theta. So instead of sine 2 theta, you will write 2 sine theta cos theta, and in the denominator we have chosen cos squared theta minus sine squared theta. Now divide both sides, both the numerator and the denominator, by cos theta. And the reason why we do that is we would like to get a tan theta here, since getting a double angle of tangent in form of sine and cos is not the best way you could have approached this. So if you divide both sides by cos squared theta, since there is a squared term involved here, so this would have given you this cos, exponent would have canceled out this cos theta. This sine theta by cos theta would have given you tan theta. So 2 tan theta divided by, and here cos squared theta gets cancelled with cos squared theta, so 1 minus sine squared theta over cos squared theta is just tan squared theta. So you get the same thing, it's nothing different, just alternate derivations of this. And there are your double angle formulae.